So the way we solve a system of equations with two variables is we're going to find, we could do it, one way we could do it is by putting both of these lines in the y equals mx plus b. They both represent lines. You might have something, I'm not drawing it correctly, but you'd have one line that might go this way and another line that might go this way. And then you would try and find the point of intersection, the point where the two lines meet. These are each represent lines because they're linear first degree equations. They meet at a single point. The solution of the system equation is the point where they meet. The value, and remember, a point has an x value and a y value. So the x and the y of the point is the solution of the system of equations. Now, as I said, one way of doing this is actually going and graphing it. But we saw that you really have to have good graph paper in order to graph it very accurately so they can find the exact point where they're meeting. And on top of it, graphing takes a lot of time. So we talked about another method of solving the system of equations, which doesn't involve drawing anything. It's called the method of elimination. Sometimes this method of elimination is also called the addition method. And both of these will give you a hint as to what we're doing. The addition method is hinting at us that what we want to do is add these two equations. Let's see what happens when we add these two equations down. Notice I have it set up, and when I use the elimination method, I want it set up that way in what's called standard format. X first, then y, then your equal sign, then your numbers, and they all have to line up. And if we line up, we can add them, and we'll do x plus 2x, and that'll give me 3x. And then when we add the y and the negative y, they both have ones in front of them that we understand. A +1 and a -1 give us 0, so there's no y left. The y just cancels out. The y is eliminated. That's why it's also called the elimination method. And when I add the 11 and 1 down, I get 12. Now, what's better about this is because I've eliminated one of the variables, I've gotten rid of one of the unknowns, I can solve, this is an easy equation to solve for x. All I have to do is divide by 3, and I get x equal to 4. Now, notice I've solved something because I've gotten an actual value, but I'm not finished because I have to not only solve for x, I have to solve for y as well. So what we do then is we go back to one of the original equations. I'll take the first one and substitute for the x. Its value, we know it has to be 4. So if I take that first equation, x plus y equals 11. And in place of x, I put 4. I get 4 plus y equals 11. And that gives me y equals 7. So now I've solved both variables. I've got x equals 4 and y equals 7. Notice it works in both equations because 4 plus 7 does give us 11. And 2 times 4, which is 8, minus 7 is 1. So it works in both. It works. If you want, you could say it checks. Unless it's a good idea to check, but you don't have to unless you're told specifically. The answer could also be written as a word pair 4, 7. Remember, the first number always has to be the x number. The second number has to be the y number if you're giving it. So this is one way of giving the answer. And this is an alternative way, which means that if you would have drawn each of these lines, you both could be put in y equals mx plus b form, and it could have been made straight lines, and you drew them, they would meet at the point 4, 7. That's what we mean by solving a system of equations. Does anybody have any questions before we do another one? Okay, so let me put another example on the board. I'm going to work the next example, and then after that, I will give you one to try on your own. Hey, does anybody need more time copying this? Okay.
No, we good.
I can erase it?
Yes, you can.
Thanks.
Yes, you can.
What?
Now saying yes, you can.
Okay, great. Thank you. I'm glad when people speak to me. I feel like there's somebody over there, not just me speaking to the wall. So I'm glad when you speak up. Thank you. Okay, so here's, and again, I'm taking the examples that I'm going to be doing now off of that practice sheet 3. So here is, it happens to be question number 1 on that sheet. It's, the question reads 2x minus 3y equals 13. And 5x minus 4y equals 22. And this is again a system of equations. We have 2 separate equations. Both of them are linear because we don't have any x squared, we don't have any exponents, we don't have anything that makes it anything but first degree. And therefore, this would represent the line. If I put it in the line, it equals mx plus b, I could graph it. I could also graph these. These would not be easy to graph because the numbers are not so easy, but essentially it could be done. But we're going to actually ask us to use the addition method, and I want to show you how to use the addition method in this case. Now there's a problem here, because what would happen if, now don't write what I'm doing now, I just want to show you something. If I just add these equations down, I'll get 2x plus 5x, which will give me 7x. And negative 3y minus 4y, so negative 3 plus negative 4. And again, if you have trouble with sign numbers, you should be using a calculator. That's going to give you negative 7y equals 13 plus 22, which is 35. And remember, we didn't just call this the addition method, we did add it. There's not only the addition method that we call it the elimination method, and in elimination, it failed. We did not get rid of either one of our variables. And if we don't, then we have to work this a different way, because the whole point of adding the equations is to make sure that one of the variables drops out. So now I'm erasing this. And I did mention this the other day, but I'm going to repeat it. What you can do is look at the equations and decide which variable would you want to eliminate? Which one do you want to get rid of? Anybody has a suggestion? Should I get rid of the x or should I get rid of the y?
X.
X, okay. If we decide that we want to get rid of the x, then what we're going to do is we're going to multiply each equation by its opposite coefficient. In other words, I'm going to multiply this equation by 5, because that's the the coefficient in front of the x in that equation. And the second equation, I'm gonna multiply by 2. Can you see those? I tried to put them in different colors. I don't know, can you see them?
Yes, we can see them.
Okay, great.
No. Well, I can't really tell. It looks the
Okay, okay. Let me do this. This is 5. Is that better? And this
Yeah,
one's
that's
2. I wanted to sort of color code it, but I guess it's not showing up so well on my,
I see the difference now. I think that's blue.
okay. So the point of multiplying them by the opposite coefficients is that then you get the same number in front of them. How can we, what do we need? We can focus on the purpose here. We'll understand what we're doing. What do we need to have in order for one of the variables to get rid of it, to eliminate it? Let's say we want to get rid of the x's. Wouldn't we need both x's to have the same number in front of them, but one with a positive sign and one with a negative? If, in other words, if I have a negative 10x, then I have to need a positive 10x to get rid of it. If I have a negative 80x, then I need a positive 80x to get rid of it. If I have a positive 17x, then I need a negative 17x to get rid of it. Two things you get rid of it when they're the exact same coefficient, but one is positive and one is negative. Because when you add two numbers with opposite signs, for example, 10 plus negative 10, that's when you get 0. And if you get 0, then you don't have any x's left. Well, if I look at this, by multiplying this one by 5 and this one by 2, I'll get this to be 10x, and I'll get this to also be 10x. But the problem is that they both are positive 10s. So but I need one to be positive and one to be negative. So I'm going to choose to use a negative with one of the numbers. In other words, first I pick the number that I'm going to multiply it with, and then I decide, do I want to leave it multiplying both of them by the positive number, which would be good if one was positive and one was negative. But if they're both positive or both negative, I'm going to have to include a negative with that number. Okay, let's see what happens here. Multiplying the top equation by 5 gives me 5 times 2x, which is 10x. 5 times negative 3y is negative 15y, equals 5 times 13, which is 65. Notice I multiplied every single term by that 5. Now I go to my second equation, and I'm multiplying by negative 2. Remember, I'm multiplying by 2 because this one was 2, and I'm using the negative so that this one will turn out to be positive and one will turn out to be negative. So multiplying by negative 2 times 5x is negative 10x. Negative 2 times negative 4y is plus 8y. Be very careful with your signs. And negative 2 times 22 is negative 44. And now I'm going to add these two equations down. And 10x minus 10x, that cancels out. It's eliminated. I've eliminated the x. That's what I wanted to do, and that's what I've accomplished. Let's go on. Negative 15y plus 8y. So negative 15 plus 8 gives me negative 7y. And 65 minus 44 is 21. And now I can easily finish this by dividing both sides by -7. So this gives me y equals -3. So I have now found the value of one of the variables. I now had to find the other variable because the solution is when I have both answers, the x value and the y value. So going over here, I can take either one of these original equations. I'll take the first one and replace the y. I now know what y is. It's -3. So I'll do 2x minus 3. And in place of the y, I'm putting -3 equals 13, which gives me 2x. Now be careful here. -3 times -3 is +9 equals 13. I'll subtract 9 from both sides to get 2x equals 4. And of course, to finish that off, I'll divide by 2 and I get x equals 2. And again, I solved my equation system of equations because I found both my x value and my y value. Again, if you wanted to, you could have written the answer 2, -3. But remember, the 2 would have to go first because the x value always goes first, even though I found it second. In the final answer, the x goes first and the y goes second. Okay. So notice we didn't do any drawing, but we solved the system of equations by what's called the addition or elimination method. It depends which book you're looking in, whether they call it addition or elimination, but both names are appropriate. Okay, I'm going to give you one to try on your own. I'm going to give you a minute to try to finish copying this. Can I erase this now? Anybody not finished? Okay, so I'm going to erase this now. I'm going to put a new problem on the board that I'm going to give you time to work out. And again, I would really love it if somebody would try putting an answer on the chat. You get credit whether it's right or wrong. So it really makes sense to try and get that extra credit. Could mean the difference between getting a B- or a C+, and that's a very big difference. So it really helps for you to get those extra little bits of credit because they add up. Okay, here's the question. (3x minus 5y) equals 7. (x plus y) equals -1. Okay, here's the system of equations. While you're doing that, I'm going to go and take attendance. So make sure you're listening for your name. Olivia. Olivia Auguste. Isis.
Here, good morning.
Good morning. Alvaro Blake. Louis Cayola.
Here. Good morning.
Good morning. Emma.
Good morning.
Good morning. Demetrius.
Here.
Hi, good morning. Desmond. Desmond Fleming. Shania. Shania Haley. Oh, Desmond, thank you. I see her here now. Okay. Caden Harris. Caden Harris. Kayla Harris.
Here.
Hi, good morning. Sanjita, I know you're here because came in number 1. Ariana Jonas. Ariana,
Yes, I'm here.
hi, good morning.
Good morning.
Tahira Joseph. Michaela Martinez.
Here.
Good morning.
Good morning.
Kiana Perez. Kiana. Carleaf. Carleaf Peterson. Jenna Pierre. Tatiana Sanchez. Naya. Naya, I know you're here.
Here.
Yeah, good morning.
Good morning.
Kazandu Small. Trina Small. Jean Thomas. Let's see on this thing. Alvaro, can you just let me know that you are here by sending me a text? Because you never answer when I take attendance. Okay, great. So I have you. Please try and answer when you hear your name being called. And the ISIS, I'm going to, that looks like the right answer, I think. Very good, excellent. And I'm giving you extra credit for that. Okay, one person is getting extra credit, anybody else? Have an idea? Isis, would you like to give us an idea of how you did this? I don't know if you want to open up your mic and talk or not. Okay, I guess not. But I do appreciate that you sent in the answer. Let's decide if we want to get rid of the X's or the Y's. I would say at this point, let's try and get rid of the Y's because I want to show you it doesn't really make a difference. You start out sometimes it looks much easier to do one or the other. Most of the time it doesn't make a difference. You just decide what you want to get rid of. I'm deciding to eliminate my Y. So therefore, I look at the coefficients of the Y, the numbers in front of the Y. The number under here, there's no number here, so obviously it's understood to be 1. So I will multiply the first equation by 1. The second equation, now I'm just looking at the number, don't look at its sign, just at the number. The number in front of the Y in the first equation is 5. And separately, we decide whether we're going to use one of the numbers to be negative. Either we use both numbers to be positive, or we use one number positive and one number negative. In this case, since the Y's already have opposite signs, which is what we want to end up with, we want them to end up to have the same coefficient but opposite in sign, we're going to use only positive numbers. So again, when we're deciding what to multiply by, and this is not, let me just stop here in a second. This is not the only way it could be done. I just teach it this way because this way for sure will always work. Sometimes you just see other numbers that will work just as well. But this method for sure will work for you. We'll just multiply them by their opposite coefficients using only positive numbers, and then after you've written the positive numbers, decide, do you need a minus sign with one of them or not? And if you decide, and you will need a minus sign, if both the numbers that you're starting out with are either positive or both are negative. And you could use the minus with either one of the numbers you're multiplying by. In this case, I don't have to use the minus because I already have this one being negative and this one being positive. Well, if I multiply the first equation by 1, essentially I'm not changing it. It stays 3x minus 5y equals 7. When I multiply the second equation by 5, I'll get 5 times negative x, which will give me negative 5x. 5 times y, which gives me positive 5y, equals 5 times negative 1, which is negative 5. Don't forget to multiply every single term on both sides of the equation by that number. You don't want to change the equation. You just, by multiplying through by the same number throughout, you're not changing your equation. Okay. If you notice, I've accomplished what I wanted to do, if that I'll be able to get rid of the y's because this is a negative 5y and this is a positive 5y, and when I'll add them, they'll cancel out. Let's do that. 3x plus negative 5x is negative 2x. Remember, be careful with your signs. Negative 5y plus 5y cancels out. And 7 minus 5 adds to positive 2. If I then divide by negative 2 to get the x alone, I'll get x equals 2 divided by negative 2, which is negative 1. And I found one of my variables. Now I have to figure out the other one. Again, I go to the first equation. Though sometimes the second one looks easier, I might use the second one instead. Using the first equation and replacing the x now by negative 1, because I now know that x equals negative 1. This will give me 3 times negative 1 minus 5y equals 7. Now 3 times negative 1 is negative 3. So I have negative 3 minus 5y equals 7. And now to get the y alone, I'm going to add this 3. Get rid of that negative 3. So I have negative 5y. And 7 plus 3 is 10. So all I could do is divide by negative 5, which will give me y equals 10 minus divided by not negative 5. Remember, this is division, it's not subtraction. 10 divided by negative 5 is negative 2. So my final answer is negative 1 comma negative 2. The x is negative 1, the y is negative 2. You can always check the equations to see if it works. This answer has to work in both equations. That's why it's called the solution of the system, because it works in both. Okay. Let's see if we can do another problem. Okay. I'm going to erase this now and put on another problem on the board. We have 2x minus y equals 2, and 4x minus 2y equals 12. Okay, I'm going to give you a few minutes to work on this. Okay, let's see if we can work on this together. Okay, again, we have this system of equations. And again, it's set up in the standard form x, y equals number. Let's get rid of, this time, our x's, just because I like to show you that it really doesn't make a difference whether you get rid of the x's or the y's. You can solve it either way. So you could multiply the top equation by 2 and leave the second equation alone, but I'm going to use my standard method. I'm going to multiply the top equation by the 4 and the bottom equation by the 2. But since both of these are positive, when they have the same sign, I have to make sure to use a negative sign with one of them. Not with both of them, but with one of them. Again, when I decide what numbers to use, I only use the numbers. I don't use a plus or minus sign. I only decide whether to use a plus or minus sign at the end. And the most I'm going to do is have one of them have a minus sign. Either they're both going to be positive, the numbers you're multiplying by, or one's going to be positive and one's going to be negative. Okay, if I multiply the top one by -4, I'll get -8x. -4 times -1 is +4y. Equals -4 times 2, which is -8. Multiplying the bottom equation by 2. Go this line yet. I'll get 8x. 2 times -2 is -4y. And 2 times 12 is 24. Okay, so now I can add the two equations together because I now have the x's having the same coefficient, but one being positive, one being negative. So when I add -8x plus 8x, it cancels out. I get 0. But look what's happening to the y's. When I add 4y plus -4y, that's also canceling out. So I'm left with a 0 on this side, no x, no y. They both canceled out. On the other side, I add -8 plus 24 and I get 16. And this is something that rarely happens, but does occasionally. When you add to get rid of one of your variables, the other variable also drops out. Now, if you may recall, I said when you have, and we talked about this on Friday, when you have a system of equations, there were 3 different scenarios that could happen. Scenario 1 was the one we've been talking about all along, where the 2 lines, they're 2 different lines that meet on one point. They have a single solution, one answer to the question. This is what we call the consistent system of equations. The one point where they meet is the solution. That's the most common scenario. Scenario number 2 is where when you draw your 2 lines, the 2 lines turn out to be parallel, and there's no solution. There's no solution to this. There's no point where they meet. These are inconsistent. This is this inconsistent system of equations. That's exactly what happens when you have a situation like this. When you get rid of one of your variables, your second variable drops out as well, and you're left without any letters, just numbers. Look at what you're left with. I get 0 equals 16. is that a true statement or a false statement? Well, obviously it's false. 0 doesn't equal 16. 0 equals 0. 16 equals 16. These are just numbers. They don't have any x's. They can't be equal. This is false. If you get a false answer, it must mean that what you have is an inconsistent system of equations. There's no solution. Because if I would have drawn these as straight lines, the two lines would have been parallel. And it's an inconsistent system of equations. So if you use, and notice we didn't have to do any drawing, we just by working out the equations the way we normally do, and having our both variables drop out, gives us this situation. Now there's something else. There was a third possibility. This is possibility number 3, that when the two lines are drawn, if you draw the first line, the second line turns out to be right on top of it. They're not two separate lines. It really is just one line. The two lines are the same line. This is what's called a dependent system of equation. And in this case, there are an infinite number of answers. Any number on the line, any number that was on any one of those lines is going to be a solution. There's not going to be a single solution. This would happen if, again, both variables dropped out, but the statement you get, let's say this would have turned out to be 0, and this would have also turned out to be 0, and you would have gotten a statement that says 0 equals 0, which is obviously true. If it comes out to be a true statement, it means that the two lines are actually the same line, that it's a dependent system of equations, and you have infinite solutions. So there are two things that can happen when both your variables drop out. Again, the most common situation is that you have one variable dropping out and not both. But if both of them drop out, look at your final statement after they dropped out. If you get something that makes sense, like you get 0 equals 0, 16 equals 16, 12 equals 12, negative 100 equals negative 100. It doesn't matter. As long as you get the same exact thing on both sides, it means that you have a dependent system of equations. But if you get a statement that doesn't make sense, like 0 equals 16, or negative 2 equals 4, anything where the two numbers are not the same, that's an inconsistent system of equations. It's a false statement, so there's no solution to that system of equations. Okay, so now let's try another. I want to show you another method of solving systems equations that again does not involve graphing, but is called the substitution method. And the substitution method is very helpful in certain situations. And when you're doing a system of equations, unless you're told to do it by graphing, you have your choice of using either one of these. And I will never specify you have to do it with the addition, or you may see it on homework because they want you to practice that, but on a test, either method that you use is perfectly all right. So I'm going to erase this and do another problem. And I'll give you then suggestions as to when I think you should use one method over the other. Here's a system of equations. My first equation is x plus y equals 2. My second equation is y equals 2x minus 1. Again, it's a system of equations because we have two variables, x's and y's, and two equations. But if you notice, even though my first equation is in the standard format, x, y equals number, the second equation is y equals, usually what we call the y equals mx plus b form, but it's basically specifically saying what y is. When I see a situation like this, where I have one of my equations either saying y equals something or x equals something, that's usually where I use the method that's called substitution. Substitution means to use one thing in place of another. And that's what we're going to do. In this equation here, the second equation, y equals 2x minus 1. What it's telling me is for this particular problem, not for all problems, but for this problem, because it's right here in this problem, there are two ways I could name y. I could call y y, or I could call y 2x minus 1. To say two things are equal means they can be used interchangeably. They're the identical same thing. It's just like calling somebody Pete, where his name is Peter. Pete and Peter are the same thing. You can use them interchangeably. So, or John and Jack sometimes. In other words, one name for y is y. Another name for y is 2x minus 1. I can use 2x minus 1 in place of the name y. So if I go to my first equation and I take in place of the y, here's my y, in place of it, I'm going to substitute 2x minus 1. All I've done is replace the y by its equivalent, it's equal to x minus 1. I end up with an equation that doesn't have any y's in it. When do I use this method? Basically, when one of the equations states y equals, or one of the equations starts x equals. Now, I can solve this equation because now I only have x's. Remember, when you have a parentheses, and when you're going to use a substitution method, you really should use a parentheses in place of the letter you're substituting. There's no number in front of the parentheses, so it's understood to be 1. So if we're removing the parentheses, we're getting x. 1 times 2x is 2x. 1 times -1 is -1 equals 2. It's really not a hard equation to solve. X plus 2x is 3x. So we have 3x minus 1 equals 2. And all I have to do is add 1 to both sides, and I'll get 3x equals 3. And that gives me, dividing by 3, we get x equal to 1. And then I can figure out what my y is by replacing it in this equation is the simplest one, because then I can do with x equals 1, y equals 2 times 1, because now we're replacing the x with 1, minus 1, which gives me 2 minus 1 or 1. And my solution to this equation, system of equations, is 1, 1. This is a different method, but notice it's also very efficient and comes out with giving us the answers. Usually, if you ask me which method should you use, my standard answer is if it's set up as a both of them in what we call standard form, X, Y equal number, both equations, and they're just lined up like that. It seems like a perfect setup for elimination or addition. But if you have one of your equations in the Y equals or X equals format, then maybe it makes more sense to use the substitution. But again, you could have even done this using elimination by just by moving things around so that you get it in the X, Y equals format, and then you could get rid of it. Okay, excuse me. No. No, the number of website is the wrong number. This is the problem. Sorry. Sorry about that. Oh, okay. I'm going to give you another problem to try, and it's probably going to be set up mostly to do by substitution, but if you decide that you want to do it another way, then fine, you could do it another way. Thank you, Naya, I see, and I'm going to give you credit for doing that. So here's another question you can try. My first equation is going to be X equals 3y minus 1. And my second equation is 2x minus 3y equals 4. Okay, so here's your system of equations. Here's equation number 1. Here's equation number 2. See if you can solve the system of equations. Give you a few minutes to try that. Then if you have an answer, put it on the chat. Let's see if even if it's not right, you get credit for doing the answer. Okay, let's see if we can work on this together. Does anybody want more time? Okay, now let's see which one seems to be the right answer. Okay. And you know what I'm going to do? I'm going to do this using the two different methods so that you can get an idea of which method you prefer using. Again, this is very much how you feel. Some people want to always use the addition method. Some people say, oh, they like the substitution method. I only use the substitution method when I have a situation like this where it says either X equal something or conversely Y equals something, where you have the X or the Y alone in one of the equations, or it could be in both of the equations, but at least in one of them. this to me looks like a perfect setup for the substitution method, because here I clearly have that x equals 3y minus 1, which means I can go to my second equation, and where I have an x in place of it, I can put the 3y minus 1. I'm going to do 2. Now here's my replacement. In place of the x, I'm putting what it's equal to from that first equation, the 3y minus 1. Here's it in place of the x. And then I'm going to finish up the rest of the equation. Minus 3y equals 4. What I accomplished by doing that is that I am now in the position that I only have one variable. Thank you, Isis. We'll see if that's the right answer. So here's a regular equation. This is how we started out our term, doing these type of equations. I'm going to multiply this 3y minus 1 by the 2. 2 times 3y is 6y. 2 times negative 1 is negative 2. Minus 3y equals 4. And I combine the like terms of the 6 minus the 3y, which gives me 3y. Of course, that this minus 2 I just bring down, equals 4. Add 2 to both sides to get the y alone. So I get 3y equals 6. And divide by 3 gives me y equals 2. So I figured out what y is. So in order to find out what the x is, I go back to that first equation that tells me what x is in terms of y, and I'll do x equals, well, now I know what y is, it's 2. So I'm going to do 3 times 2 minus 1, which is 6 minus 1, or 5. So my solution to this system equations is 5, 2. And I think that's exactly what Isis said perfectly. Naya, you were right that it was 2. It wasn't negative 1. So, but I'm going to give you both extra credit for doing this problem and putting the answer on the chat. So Naya, this is and Isis. Okay. What I'm going to do now is I'm going to, before I end this class, I'm going to show you, suppose you don't like the substitution method. I'm going to show you that we could have done this problem using the original elimination or addition method that we talked about in the beginning. Okay, I'm going to leave the answer on the board to show you that we will get the exact same answer, even if I use a different method. Now, I'm not graphing it, though that's another way of doing this. I am solving this by addition. Okay, I'm going to erase what I have over here and show you an alternate method. Does anybody still need this work on the board? Remember, you can always, if you run into, you want to see something again, this has all been recorded and it's been posted on, it will be posted, this one hasn't been posted yet, but I post each of the day's recordings on Blackboard in our recording in the section that says recordings of the course. And I've done each lesson with the date of the lesson and the basic topic of the lesson so that you can refer to whichever one you are looking for. Okay, so here, let's go back and go back to our original equation that we're going to do using the addition method. Now, if I want to use the addition method, I have to get the first equation into what we call standard form, x, y equal number. And in order to do that, here I'm starting with x equals 3y minus 1. I have to bring the y to the other side of the equation, so I'm going to minus 3y from both sides. So that I will end up with this equation being x minus 3y equals -1. That's just moving the y back to its original place if we want to have it in what we call standard form. Now my system equation consists of x minus 3y equals -1 and 2x minus 3y equals 4. So now I have them set up the way I like it for the elimination, the addition method. So let's decide we want to get rid of the y's. I'm just using y's because it looks like a little bit easier. And if you notice, I don't really have to multiply by anything because they already are the same number. They both have 3 as a coefficient. I could multiply the top equation by 3 and the bottom equation by 3 as well, just using my standard method, and it'll give me a totally right answer, but it doesn't seem to make sense. If they already have the same number, why should I play around with that? The only problem that I have is that both of these coefficients are negative. And I know in order to eliminate, I've got to have one being positive and one being negative. So that's easy to accomplish. All I have to do is multiply one of the equations by a -1, because when I multiply by -1, it's going to change the sign. I'll take the first equation and multiply by -1. Remember, when I use a negative, I only use it on one of the equations. I don't use it on both because I only want to change the sign of one of the, I want one to be positive and one to be negative. Since they're both negative, I'm multiplying by -1 on this top equation so that it'll turn out to be that one is positive and one is negative. Multiplying this top equation by -1 gives me -1x plus 3y, because -1 times -3 is +3, equals -1 times -1, which is +1. Again, be careful to multiply throughout the whole equation, both sides, every single term. Okay, I'm going to leave the second equation alone. I'm not multiplying it at all because it's already okay. And if you notice, when I add these two equations together, I'll get -1x plus 2x, which will give me x, plus 3y plus -3y. That's what we're trying to do, get them, they're being eliminated because they have the same coefficient but opposite signs. And 1 plus 4 is 5. And I right away got x equal to 5. And then I could go back to either one of these equations. I'll do the first one. 5 equals 3y minus 1. And just solve that to get the y. Will give me 6 equals 3y. Which will give me y equal to 2, which is exactly what we had gotten before. 5, 2, x is 5, y is 2. And using the addition method rather than the substitution method. Again, both methods work. Just look at the setup. Remember, if you have it set up as x, y equal number, it seems to make sense to just go with the addition method. If you have one variable explicitly in terms of the other, x equals something or y equals something, then it seems to make sense to use the substitution method. Okay. Don't forget, tomorrow we meet. It's Thursday, and Medgar Evers is following a Monday schedule. So we meet tomorrow just like we did today. And we have Friday class as well. We're going to continue this system of equations. Don't forget to look for homework on Delta Math. Again, for anybody who wants to, I will be on by like 7:45 tomorrow morning. So if you want to ask me questions on anything that's bothering you, you can certainly come on earlier. Again, Patrice is in the math department, which is in the science building L00. That's the main floor 00 on Tuesday from 1 to 3 and on Friday from 2 to 4. If you want to meet with her in person, you can also email her pawilliams@mec.cuny.edu. I'm going to put that on the information page of our Blackboard account. But again, if you want to meet with her in person, if you feel more comfortable being with an in-person type of situation, she's our master tutor and she will help you with this. Again, tomorrow we will meet at 8:20 as usual, at the usual time, but again, it's on Thursday. Does anybody have anything they want to ask? Okay, so then I'm going to end the class for everybody. Have a good day. I will see you tomorrow.